which is one of our published work of recent, where machine learning has been used to estimate or predict the possibility of someone likely suffering to predict the possibility of someone suffering to suffer from anxiety. So we've had a first or third episodes. Like I said, this is going to be the last episode on this paper, and a couple of stuff will have to be clarified. So we shared the paper last time we discussed. It's a free access paper, open access as they call it, so anyone can have direct access to it online. So today we're going to look into few salient points. So following some of the feedbacks and questions that came after our last class. So we started by looking at of course, the title is very, very important. So when we have our work, it's very important we look for the appropriate medium, which has to be very relevant to what we are working on. And now we have tools that can support us in locating the appropriate journals. So if it is Elsevier, you have the journal finder there. You just need to go search it out. You have the Elsevier journal finder. You put the abstract of your paper and the title of your paper. And sometimes maybe keywords, these are optional. And you search, and then it will list out for you several journals that might be relevant to your work. You now check them out. Are they free? Because some journals are available for free. Do you need to pay money? Are they open access? These days now, majority of the journals they've started supporting both the subscription base and the open access. Open access means you have to pay for them to publish your work. So once that is after they've reviewed the work and they found it to be worthy of publication. So to clarify that, they find that a journal is open access doesn't mean it is a junk journal. No. So there are a lot of journals that are really top. If at the same journal we have subscription tab that, okay, you don't have money, you don't want to pay anything, it's fine. You submit it. You choose that option while you are during the submission process. See. So why for the open access, and the advantage of open access is your paper become available to so many people once it is published, because anybody can just go online, read it, and cite it. You know, if you cannot read the paper, it might be difficult for you to cite the paper. So the main advantage of open access is the research outcome becomes available to majority of people or many people, unlike the subscription base. You don't pay money, maybe you don't have payment, you don't have money to pay, or you don't have a research grant to pay from, because some of them could be really very costly. So you just submit it and choose the option of subscription base, not open access. And then the two will pass through the same procedure for some of these top journals. The same procedure. The fact you are paying, it doesn't give you advantage over the one you are not paying. Of course, for some journals, paying might speed up the process. So there are some journals like that. In fact, some journals don't have the free option. No, compulsorily you need to pay. But there's some of the Elsevier journals and some other publishing houses, they have these two options. They are very flexible. You have grant, you pay, and get your paper to be open access, because the main advantage of open access is supposed to be coverage, that many people will have access to your work. So you are not supposed to have any advantage in terms of your paper is going to be accepted quickly if you are going to pay. This is not supposed to be. Of course, you cannot rule it out in some or few journals, depending on their standards and also their own kind of a business model. Because some journals, they don't have subscription base. Subscription base means the journals, university libraries, research institute need to subscribe to them to be able to have access to their journal, and that is how they make their money. So if a journal doesn't have subscription-based system, then it has no option but to charge money for every paper that will be published. Because the moment you publish your paper in open access, everybody can see it. So there's no way they can get money from that kind of published work. Now, that is clarifying on that. So, and to also clarify that we can always get our work published in none of the option that is available. Now, as we can see, that is the prediction of generalized anxiety level during the COVID-19 pandemic, a machine learning-based modeling approach. We discussed extensively in our last video how you can write abstract, because it's very, very important. Even when you have a subscription-based journal, which is not open access, people will not have access to your full paper, but the abstract is always available for free. Either public, open access or not open access. Abstract is always free. So people will always read your abstract. That is why you need to pay more attention to what you put in the abstract. In fact, once you read an abstract, or a reader come across your abstract, if you are able to convince them that, oh, it's really worth it for them to get this paper, even if it is $10 per paper, or even if it is more, they will go ahead to pay for it and get it so that they can read it. That is how powerful your abstract should be. See, abstract is like the gateway, is that the wind is like the window to your publication. So that is why, as short as it is, you must make sure that your abstract is all encompassing. It will tell us what you want to do or what you have done, why you did it. So what is the justification from the advantages point of view? What is the justification from the gap identified from literature? Something could be important. However, some people already did it. Then why do you want to repeat what they have done? So you need to let people know, people work on this area before. I'm not claiming to be the first one. However, these are the shortcomings. Why we still need to work on it, to improve upon it. Make it very clear without any ambiguity. Then you talk about how do you want to do it? See, that is the method you want to use, the solution you are proposing, and the why of how. Why are you using that solution? Why don't you use solution A, B, C? Why are you going for solution D? These are very important information that someone or reader or even reviewers want to see in your abstract. Then finally, you need to tell people the result you achieve. Abstract will not, after you have explained all these very nice motivation, objectives, then what did you achieve? So you need to be able to summarize your result in a very catchy and interesting manner so that it can carry people along. It can convince me that, oh, I need to buy this journal, or I need to go further and read the entire article. Then, of course, we also explain to ourselves that the introduction, because usually when you write abstract, you have so many things to write, but there's no time for you. There's no space. Some abstract could be as little as maybe 150 words. Some could be more or less. So you don't really have the luxury of space when you are writing abstract. However, introduction, we solve that problem. We compensate for that lack of space. So in introduction, you are practically writing almost the same thing like abstract, but in more detailed format now. So you have the opportunity to include as much stories you want to tell. However, the similarity between abstract and introduction is that they practically contain the same thing. One is more detailed, supported with as many citations as possible, and that is introduction. It's like a detailed abstract. When you tell me what you want to do, don't just define. Tell us citation that define that subject. Let us show that you've read a lot about this particular topic. You see, reviewers don't like it, actually. It shows you are not just using your own very little knowledge in that area. So when you have so many citations in your introduction, it's an indication that, yeah, you have read a lot of work in this area. So define the subject, give citation to that. You can see as far as the beginning, we have citation, the consequences of lockdowns on mental health have been substantially investigated. Give as many citations as possible that shows that, yeah, you are really in tune with what is happening in that area. You cannot just pick a data and then that is all. So what you want to do, Why are you doing it? I said, why could be from 2 points of view. Tell us the advantages. What is the opinion of what that organization regarding anxiety? Tell us nice stories to make us very interested in your paper. And then the why from the point of view of the gap identified. So let us know people work in this area earlier. However, no one ever used machine learning or something related to that. Tell us the justification. Even if they have used machine learning, what is the contribution you are bringing onto the table? What are you doing differently? So why do you still need to do it? So introduction provides you this kind of opportunity to discuss in more detail what you have summarized in your abstract. Because in abstract, you cannot make any citation in abstract. Let us get that very clearly. Now, so once you write your introduction, so which is very, very important, again, after your abstract, so create as many scenarios as possible to make things very clear. Like I said, we've shared this particular paper and we encourage us to go through. It's a very simple, well written and a very simple, written a very using English, simple English format. Now, what we have done with that, the next we also explained was that you need to do your literature review the literature, and which is where you are going to, if you can summarize your literature, we call overview of the review sources arranged by date of publication. If you can summarize your literature in this one, that would be very nice. Title of the paper, objective, method used, findings, then limitation. You can see, so what are the findings? People work in this area before, but these are limitations of those areas. You see, either data was from one geographical area in China, they only included self-study reports, and so many other people also have their own limitation. What I've done here actually might be what we motivate people to actually read more, to read your paper the more, because they want to see, oh, some of the limitations of the earlier work, because limitation of one work can lead to your own proposal, by the way. It might be the basis for you to make proposal. It means there are so many limitations that have been identified based on the literature review carried out. So once you are done with that, so then we move for that to where we do what we call a description of proposed techniques. See, you need to describe the proposed techniques. We also clarify this. It's good if you can link it with what you are doing. Of course, a generalized description. We are using support vector machine and the decision tree, but you can link it to the problem we are solving. That would be very, very wonderful. So, and mathematically, I've clarified that never copy paste mathematical expression. You need to type it out using math type. That's what we call math type. Or you use the Microsoft equation. If you are using LaTeX, it also has its own equation typing scheme. So that is to make it work professional. Now, to the main work when you talk about machine learning, which is really the empirical studies, once again, say this is here you're going to describe your data set, make it very clear. If your data set is totally new, make it clear. Is it possible for people to get your data? Is it from you? Make it clear. If you get the data from somewhere, it's become compulsory for you to tell us the source of that data. Maybe provide the link appropriately. So tell us the kind of data you're talking about. Is it for classification or regression? How many samples? As you can see here, they are all detailed. You have different tables describing the different variables. So nationality, gender, age, marital status. These are most of them. So then we also talk about the correlation, which is one of the areas we really want to touch today, because people ask questions regarding the feature selection. There are different types of feature selection. So we've discussed this earlier, so we can also refer back to some of our videos on feature selection. However, this very simple feature selection that has been used here, and which I usually recommend for people starting machine learning, is what we call correlation-based feature elimination. And then we incorporated the idea of recursive. So once you have your attributes, try to calculate what is the correlation between these attributes, each attribute, and the target. See, correlation between each attribute and the target. So you can calculate it. What is the correlation between these and these, because this is what we want to predict. So you get the correlation, and it has been arranged in descending order. It means question 31, 32, 30, they are highly correlated to the target. It means that they're having likely they're having better information that can assist us to get better prediction. You see, of course, sometimes it's not really the case, and that is why the exhaustive feature elimination method is also an option. Because sometimes you can look at this region, the region someone came from. It's having 0.05, very small, very small. However, maybe if I combine this region with 1, 2, 3, maybe that could really make the work to be better. This is about exhaustive feature elimination. You try combination of multiple combination, A, B, C, D, E, F, A, B, C, A, B, D, C. You keep doing that. There are another way to do it, but it's very exhaustive, takes a lot of time. We have not done that in this particular work. But what we have done is to do very simple and kind of a little bit reasonable, that if you are not really correlated well, maybe you are not really going to have something to contribute. But what I'm trying to clarify is it's not in all cases. If this simple feature selection method does not work for you, don't lose hope. Maybe other feature selection methods will work for you. This is the message I'm trying to pass across to all. So for our own case, this is what it worked for us. And it's always good in machine learning to start from the simple. Start from the simple idea and then go to complicated ones if it doesn't work for you. So if correlation-based feature selection will work, then why should I go to exhaustive one that is going to be time-consuming? And at the end of the day, maybe I will still get the same result that I'm going to get if I had used the correlation-based feature selection. So this is the selection procedure that we recommend. As we always say, keep things simple as much as possible. It is when the correlation-based feature selection failed, then we can then go to more complicated options by trying to explore until we get better result. However, never miss simple solution while focusing on bigger or more complicated solution. This is not how to solve machine learning problem. I hope we get that. Now, the same thing has been done because there were two data sets. The same data set, but the difference is one of them is having 2 classes, while the other one is having 3 classes. You see, one is having, is it anxiety or non-anxiety? The second one is testing level of anxiety. Is it low? Is it medium? It is high. That is why you have 3 classes and you have 2 classes. Now, so we've explained this. We explained this also later. We also talked about the statistical analysis. And remember, one of our members has the question, if you have to do normalization, if you have to do normalization, see, because sometimes when we look at the attribute, the mean, the median, if your data, especially if the minimum and the maximum are far away, you see, this data set doesn't have such a problem. The maximum is 30, minimum is 0. This is fine, it's still okay. But our data set whereby you have the minimum is like 0 and the maximum is like 10 million, and you have different variations like that. In that case, you might need to do normalization. But still, I encourage people to, first of all, try to run your experiment, let the data speak. It is when the machine learning algorithm you are using is not able to deal with that data as it is, then you can then try to say, okay, maybe I need to normalize this data. Because sometimes leaving the data as it is, of course, we want to work with original data as much as possible. We don't want mutilated data or manipulated data. We go into those manipulations if things are not working the way we want, actually. Again, it's in line with the principle, keep it simple. So let the data speak. So run the experiment. If there's something, then you go back to your data. What could be wrong? Oh, I can see that the maximum is really huge, 10 million, but minimum is 0. Okay, can I normalize this data? In that case, when you normalize each of those attributes, even that is 0, 30, if you can normalize that everything should be between 0 and 1, or between -1 and 1. So you can see that the range becomes very limited. When you have data set with limited range, usually it's easier for machine learning algorithm to be able to model it appropriately. Of course, it depends again on the data set. And that is why let the data speak. So don't go ahead and start normalization. Test it first, check, see what you can get. It is when it is not going the way you want, then you can start thinking of, should I normalize? Then on normalization, now the question is, if we normalize our data, are we going to produce another statistical table now? Because that's the question. You know, when you normalize the data will become a little bit different from what you have originally. So should I represent it in a table? Well, this is up to the person and the available space. If your space is there, you can do that. However, it's not compulsory to represent the statistical analysis of the normalized data. However, let the people know the method, the formula that you used in normalizing your data. This is the one that is compulsory. Because if you don't tell them the normalization option you have used, there's no way they can know it. So in this sense, but repeating another statistical analysis of the data is optional, because some journal will give you have maximum of 10, 15 pages to produce. In that case, even if you want to do it, there's no space for you. But what is compulsory is let them know we normalize this data using this formula. They understand. They can also check it for you if they want to cross-check. Now, so another point here now, since we are on empirical work, which is the real experiment, the next area to look into is the experimental setup, which I told us that in the experimental setup, we have to make sure that we describe how we carried out the experiment. Every assumption that someone cannot search on Google and get, we have to mention it to people. So everything in the data, everything in the experiment that cannot be understood by people reading your paper must be mentioned in the experimental setup. Because if it is missing, then there's no way people can repeat it. So this is what we have to look out for in the experiment. The solution is ask yourself a question. If I didn't tell them this, is there any way they can find it out? If no, then you need to mention in your experimental setup. You see, but don't go to too much detail, how to run experiment, how to use Wika. This is not what is expected in this particular section. Now, so having done the experimental setup, it cannot be more detailed. So provide as appropriate information as possible. This is the clear message here. If you can support your experimental setup with a flow chart, that would be very nice, but it's not compulsory. That is, you tell us the flow of information through your experiment, how you partition your data, then after that we use normalization. After that we use feature selection. So because flow chart make it easier for people to be able to follow the experimental setup in a clearer and easier manner. However, it is not compulsory, but it's one of the stuff that we can present in our work. Now, because the essence is we are communicating to people that we might not be available. We will not be available when they are reading the paper. So the more clarity we provide in our work, the better, so that it makes it easier for them to follow. Because the moment they are getting so much confused, these are some of the reasons why reviewers reject the paper. So that is why some things are not compulsory, but if you can present them to make it more clear so that they will not face, because you are not there to answer questions. And for some reviewers, once the number of questions they are going to be asking you in the review report is getting too much, then they just conclude that this paper has so many issues. Please reject. So, and that is why as you are writing, you have to put that in mind. And that is also why as a researcher, it's always good for someone to also be a reviewer. Try to be a reviewer for some journals, actually. So whosoever is already, please stick to it. If you're not yet a reviewer, if you are interested, you can let me know. I can recommend you for some journals. It's good to be a reviewer. But when you are a reviewer, you can always look at it from the point of reviewer. So you know what, when you are reading someone's paper, that will also prepare you well to be able to write your own paper well, actually. Because you know, when you're on the other side, it's always easier. So look at it as a viewer. Oh, this guy, this is amazing. So when next you are going to write your own paper, you also have an idea of what an average reviewer might possibly be looking into. Now, so that is on making your experimental setup as clear as possible. Then the next is under the experimental setup, what we call the performance measure. Tell us how we are going to measure the performance of the model being developed. Also the parameter optimization strategy. We use a very simple one, which is, I call it systematic parameter optimization, systematic search, whereby you start searching one parameter, keep the others constant. Once you get the best value for that parameter, you move to the next one until you finish all the parameters. And if you can plot something like this to see how each of the parameters fluctuate with the data in terms of performance, that would be good. It's not compulsory, but it's one of the way of convincing your reviewer that you have really done this particular work. Now, and the last but not the least area we want to talk about under the result and discussion. Yeah, so we talk about what are we getting. Tell us, even before feature selection, already support vector machine is getting 100% in both 2-class and 3-class classification problem solved. So whereas this 48 decision tree is still struggling it's gotten up to 95.79. So we try to say, okay, discover what we have gotten and then try to see, can we get feature selection? It's not compulsory, but it's always good because feature selection might make you to be able to get better result. Someone will ask me, okay, but we already got 100%. What can we get better than 100%? Then another advantage of feature selection is that instead of having 31 questions for your interviewee, if you have lesser questions, for sure, that's going to be better. Imagine we want to develop a predictive solution for maybe medical application, and we're asking people to do like 30 medical examination. That is too much. Can we reduce it to like 5 and still get the same result? You see? So that's why feature selection is not only to get better result, but sometimes to reduce the computational complexity or to reduce the resources that we're going to need in gathering the data set. So that is why we still went, even though we already get 100% with SVM, we went high with feature selection, and we used the simple feature selection idea, which I call correlation-based feature selection, using the recursive feature elimination idea. So, and what is it? You have all the features. You see, we run the experiment using all the features. Then remember in the correlation table I showed to earlier, we already had the correlation values arranged in descending order. So keep dividing them by 2. So 20 features divided by 2, that would be 10. We pick the best 10. That is the 10 with the highest number of correlation values. So next one, divided by 2 again, you choose the best 5 attributes. The next one is divided by 2, that's going to be 2.5. You round it up to 3 because we don't have 2.5 attribute. So you round it to 3, you choose the best 3. 3 divided by 2, that's going to be 1.5. Round it to 2, you have the best, you choose the best 2. You only stop when the number of features becomes 1, because when you divide 2 by 2, that becomes 1. Then run the experiment for each of these cases, and you can see here, we got 100%, we got 100%. At this level, the experimental outcome started going down. So in that case, since I'm getting 93.5 better than this one, you can see we even find the average. That is, the average is this plus D divided by 2. You can see here gives us better average result. Even physically, you can individual. This is 100. This it doesn't change. But now the big change is instead of using 20 questions to solve this problem, we are going to have only 10 questions. Just imagine that is an exponential reduction divided by 2. See, that's a big reduction. That is, we are reducing it by 2. It means instead of creating 20 medical tests, we are going to have to, or questions, we have to create only 10. And we are still getting the same, even better result now for the case of G48. So that is why in feature selection, we want something to improve the result, or at least don't get less than the best we are getting before. This message will be very clear. You see, you don't want to get less than what you are getting before the feature selection. You see, you don't want to start getting, the moment you start, that's why we will not go for 5, because it's really very low, 93. That is getting very low. But in some areas where really getting the features is a big issue, maybe some application will say, yeah, we can still go for 5. 93% is still excellent. In some predictive solution in material sciences, it's still very acceptable. In fact, they get 70-something% accuracy, they celebrate sometimes. So it depends on the area. But this is medical application. We want something as close to excellent, super excellent as possible, 100% or a little bit lesser. So that is why we are satisfied selecting 10 features as the best number of features to be used. So this is how we use the feature selection. The same thing was done for both the 2-class problem and the 3-class problem. And they all indicated that, okay, by trying to reduce the number of features, we can actually get even better result for G48 while reducing the number of features for both of them. So that is why finally you see here that for 2 classes, you can see SVM is having 95, while for 3 classes, G48 is having 93.5, it's having 95 here, while SVM is having 100 for the 2 problem. And that is very, it's clear, it's natural. The more the number of classes you are solving, the more challenging to get the result. And that's why the decision tree could not scale up. You can say 95% for 2 class. 2 class means yes or no. It's easier. When you have 3 classes, it becomes more difficult. You see, because you are trying to partition it to 3 now. If it becomes 4, more difficult. It becomes 5. So the more the number of classes, the more challenging it becomes. And this is demonstrated in this particular case. And it's one of the things that you need to discuss when you are discussing your result. Why is it that this particular thing is like this? What could be responsible? We try to discuss our work to be able to communicate to our readers why the experiment result or outcome are as such. So that is regarding the feature selection, which based on feedback, we needed to actually clarify some of those points as we have done. So, and that's actually brought to the end of that particular paper, because the next is other discussion, try to add the feature, I mean, the correlation, the confusion matrix, the ROC, try to see which ROC is better for us, and then discuss your result. What is the implication of what we have gotten? Why do you choose a perfect machine is getting better result than decision tree? Then why is decision tree getting lower result in the 2 class compared to the 3 class? This is very straightforward, because the more the number of classes, the more kind of challenging it becomes in actually classifying the system, and of course conclude our work as appropriately and it should be. So this is what we're going to have finally on the anxiety paper, and we're going to give hopefully time if there's any needed clarification from the audience. So we are going to take it, and for sure that will be the last discussion regarding anxiety paper that we started a couple of weeks ago. So hopefully it's inspire some of us working on our papers to be able to see where to focus more attention on and how to make our report better. In machine learning, even for people who are not in academics, it is very important to present your work. It's not just something you do on your machine and forget about it. No, report writing is part of machine learning, even for people that are not in academics. Yeah, you need to document what you have done. That's why you go online, you see a lot of work online there. They are not publishing it. They just show to people what we have done. You have to tell us how you did the experiment. You have to tell us the kind of partition you have used, the result, the ROC, and so many other things. So documentation is part of machine learning, even for work that are not meant to be published. So it's not something we can actually escape, both academic and non-academic people. So hopefully we've gotten one or two things. So we're gonna give room for some questions. Thank you very much for listening. Wish you all the best. Thank you.